We're going to do a practice problem with energy. I always start my problems by writing the equations. For energy, we just write the two general equations. Potential energy equals mass times gravity times height. Kinetic energy equals 1/2 times mass times velocity squared. Now we're going to read the question and see where it takes us. A model rocket with a mass of, so we put mass, right, our givens over here, 0.110 kilograms, is launched into the air with an initial speed, so the velocity initial is 72 meters per second. How much kinetic energy will the rocket have? So how much kinetic energy equals question mark at a height of 184 meters. So I'm going to do a 184 right here. So the height then becomes 184 meters. Assume there is no wind resistance. So this is what we have going on. We have a rocket. There's my little rocket. He's going to go up, right? And then he's going to land over here. Okay. So initially when the rocket takes off, right here, all energy is kinetic. Okay. At this point up here at the very top, the rocket's engine has blasted off and it exhausted all the fuel, and then it glides up to the top where it stops. And all of the energy is potential because it has the biggest potential to fall. Okay? So these numbers right here, this will equal this. Okay? The potential at the top equals the kinetic at the bottom when it takes off. And then as the rocket falls and just before it crashes, all of that potential is now all kinetic again. And anywhere along that path, the rocket will be above the ground, so it has potential, but it will also be moving, so it has kinetic. So anywhere along this path, at any point, the potential and the kinetic of that rocket has to equal all of the kinetic energy, or possibly all of the potential energy. So all of these equal each other. So what we have is a rocket being launched up with initial speed. So we know the initial kinetic energy. Okay? That has to equal the potential energy at 184 plus whatever kinetic it has at 184. Okay? And this is what we're trying to find. We're trying to find this kinetic energy at 184. So I'm going to plug in my kinetic energy equation for this and my potential energy equation for this and see what we get. 1/2 mass times velocity squared, and that's initial, remember, equals mass times gravity times height plus that kinetic energy at 184 meters above the ground. So now we plug in our numbers. We have 1/2, the mass is 0.110, the initial velocity is 72, mass is 0.110, gravity is always 9.81, and the height in this case is 184 plus that KE 184, and that's what we're trying to find. Remember this right here. So we're going to use a calculator, 72 and it's squared, so we're going to multiply by 72 again, times that 0.11 equals times that 0.5 equals, so we get 285.12 equals, over here, we got 184 times 9.81 times 0.110 equals, this is 198.6 plus the kinetic energy that the rocket has at a height of 184. So I'm going to minus 198.6 minus 198.6. Move my camera so you can see. There we go. So the kinetic energy at 184 meters is 285.12 minus 198.6 equals 86.5, and it's energy, so it's in joules. Now the answers to these questions are multiple choice, so you want to choose the multiple choice answer that's closest to 86.5.